right. How's everyone's day been?
Not bad. Busy, but not bad.
Oh, good. Sometimes busy is good.
Yeah.
Yeah, sometimes.
Any questions with the lesson 7?
Not
Yeah,
really.
kind
It
of
seemed a lot like
similar
number
to-
6.
Yeah, I was going to say it's kind of similar to the last one.
Yeah.
Yeah.
They just added an extra step with the z-score, so
Yeah,
it's pretty much the same.
I agree. All right. Just pulling up. All right. Okay, I've got my quiz
Okay.
up.
So do I.
I got it up. First 2 questions are easy. So nice to be not at work and having to do this. It's so stressful.
Bless your heart. Well, you handle it with grace every week. I'm always amazed.
Okay. Are we ready for the first one, or have you guys done it?
First
pretty
one's in
easy.
number 3.
Yeah.
I have not
basically
started it yet.
We're basically just plugging in that z-score into the app and then looking at the area to see what it reads.
Oh, I didn't open my applet. Hold on.
Yeah, so then the 0, it would just be the 0.175, right?
Yep. You round up the 4.
Sometimes I feel like I'm overcomplicating these, and I'm like, dude, this is easy.
Yeah, I do that. Are we good on number 3?
Yes.
So I marked number 2 on the second one. The distribution of the sample means X with a little line over it. And then number 5 is that law of large numbers.
You said the law of large numbers?
Yeah.
Which one was the central limit theorem?
On this one, let me go back.
The central limit theorem is when the large or the oh gosh, I gotta look at my notes.
Yeah, I have to look at my notes, but
The sample size increases and becomes large. The distribution of the means is approximately normal. It's
Okay.
when you've got a skewed parent population.
for number 6, I came up with 1.045.
Can you walk me through how you did that?
You take the 160. Oh wait, that might not be right. The 160 plus or minus.
What is the z-score according to diagonal score? So the 160 minus the
Yes.
mean
Let's go
of
back.
150.8,
Right,
right?
0.8. There we go.
Over divided by
And
the
then
standard deviation of 8.8.
Right. 0.8.
And that would give you the z-score, right?
Correct.
And then
That's as easy to figure out. Okay.
I have like a tiny little window on my screen. I don't know how to make it a full screen. So I have to keep scrolling up and down, up and down.
Try control and the plus sign on your keyboard.
Okay.
Because mine was that way too.
You get this little tiny window at the bottom.
Yeah.
Well, it helped a little bit. It's just making the letters bigger.
Oh, is it not? Oh, maybe it's not
Yeah,
helping,
it's not
right?
it just made the letters larger.
And you got 1.45, you said?
Let me go back. 1.045.
Yeah, sorry, 0. I forgot the 0 in there.
Which gives you, for number 7, if you plug it in, it gives you 0.148.
Mm-hmm. Yep.
Somebody's vibrating. Come on, where am I? What answer? All right, next one.
Sorry, I couldn't hear what y'all were saying a minute ago. Did you got for the number 7, you got 0.159?
Oh, I had 0.148.
What was that, Gina?
I got 0.148.
Okay, so for number 8, I know I know that the mean would be
Oh, yeah.
160.
Okay.
Yeah.
So basically for number 8, what you're going to do is take the answer from number 7 and plug it into your applet because it's the z-score for what they're wanting. And they're wanting everything above the z-score for the 160,
Okay.
right? Is that what you did,
So,
Gina?
so would it be 0.441?
No.
I
Hang on
can
a
barely
second.
hear you guys. Hold on. Let me see if I can figure this out.
Oh, wait, I think I might know what I'm doing wrong. Oh, wait. No, I'm still lost.
Oh my, I'm a little lost. This is a tricky one.
Which one are we lost on?
8.
So we'd have to find the sample mean of those. And since they're 5, oh wait, that's the median.
Mean is 160. Because I thought the mean was just 0.
Okay, so the mean is the sum of all of the variables divided by the number of variables.
Yeah, so it's 160. Oh, I see. Okay. So then, okay, cool. So then, yeah, we can essentially just do the same thing that we did with number 6. Give me a second to think. So,
Hey, Val. Okay, I'm on the phone for class, guys.
I'm stuck on number 8. I'm not sure how to do this one.
Wouldn't it be the same as number 6? Because the mean of the samples, if you take the 160, 175, 163, 149, and 153, add them all together, then divide them by 5, you get 160.
Okay.
That's your mean of your sample size. So you take your mean and you plug it into your z-score formula, which is essentially the same problem same
as number 7. So the z-score is 0.148. But then would it just be the same? 0.148?
The 1.045?
Yeah, that one, my bad. I
That's
got
okay.
With 7. Yeah. So wouldn't it just be the same, 1.045?
Yes, that's what I calculated it at.
Well, we can try that because so essentially number 8 is asking what the z-score is of 160, and then number 6 is asking the same thing.
Yeah, and then 9, that's how I'm reading it.
Like I know the difference is that with number 8, we're taking an average and putting it on the scale of average means. As like I think they're the same. So
hold on. What is the z-score? Oh wait, the sample mean. No, okay, so that is from this lesson. It's the combination of, so it would be the z-score equals our x minus our mean over the standard deviation divided by the set, the number of the set. So that in this case, it would be 5. Does that make sense? So I did it wrong.
So then it would be
the square root of 5. Okay.
Oh, so take okay.
So okay, so that's right. So we're combining the two. When we would review our from lesson 6, when we did the figuring the mean and the standard deviation of the set.
So you add up the numbers and you find what the mean is.
Right. So we did that. We added up our 149, our 153, our 160, our 163, and our 175. We added all those together, got 800, divided that by 5, got our 160. Okay, so there's our mean for our set. So we took that, and now we've got to plug it into the finding the probability within. Is it the probability within the distribution? of the sample means. So, okay, so we're finding the z-score first, and then we'll plug it into the applet and get the probability.
Okay.
So in that case, the formula for that is the Rolo, please stop. The z-score is that our observation, what's our variable? The x minus the mean. So 160 minus, wait, what's our x?
5, isn't it? Let me think.
X is the mean, so X is 160.
Okay, because that's our sample. Okay. So that 160 minus our mean for the problem, which is the 150.8.
Yep. So that would give us the 1.045.
No, because we have to take on the bottom half of our equation, we have to take the 8.8 and divide that by the square root of our set, which is 5.
So
Because there are 5 numbers in our set.
Okay. So that gives us the 9.2. 9.2.
No.
Okay.
Okay. So how did you get your 9.2?
Me? So
Yeah.
no, because I saw 9.2 because if you take 160 and subtract 150.8,
Okay. Okay, so that's okay. Because I took the 8.8 and divided it by the square root of 5 and got 3.935. So if I take the 9.2, divide it by that, 3.9935. We get a 2.338 if I round up.
0.338. How'd you get that?
Okay, so we did the 160 minus the 150.8 for the
Right.
top. And then for the bottom, I did the 8.8 because that is our standard deviation, divided by the square root of 5 because 5 is the set.
Right.
And then got the 3.935 and then divided the 9.2 into the 3.935.
Okay.
Does that make sense?
Yeah.
And that should be our z-score for that problem.
Right.
Okay, so then now for number 9, we can punch 2.338 into the applet.
Correct.
So it would be 0.0097.
Yep.
Yeah, and if we round it up, it'll be 0.10.
I didn't think we were rounding that high.
Yeah, that's pretty high.
Oh, it does say 4 decimal places. Okay. Never mind. Don't round. Everywhere else it said 3 decimal places, so I thought we were doing 3 decimal places, but this one says 4.
Okay, 10's obvious. It's obvious that it's normal because, I mean, you have a large data set, so.
Yeah. Yep. I can get down to it eventually.
Distribution. All right, so for number 11, for some reason I'm having difficulty putting this equation together.
Yeah.
Yeah.
Okay, so for the mean of the distribution of sample means, that would be the standard deviation over the, square root. That's what I'm not doing. Square root of 81.
Right.
Yeah, taking this quiz, I'm like, I'm definitely gonna have to go over this with my tutor.
Okay, I got 0.0777777. Anybody else?
Nope.
I'm not gonna be able to get a more accurate answer.
Trying to
So
read my notes.
0.078.
Yeah.
All right, we can try it.
I mean, that's
Yeah, because I'll be going to I'll here, give me a second. I need to look and see. So since I'm going to BYUI, we have what's called a math lab. And it's nice because there was like a whole bunch of toodles there just like walking around all the time.
Yeah.
And if you need help with something, you just raise your hand, someone comes over and they explain it to you. And I think they were open until like 9. So if they all, then I'll be going sometime before then tonight, and I could send you guys explanations on how to do it.
Yeah.
Sampling distribution.
Yeah, they're open until 9. So, yeah. So, I mean, we don't have to stress too much since we have 2 tries. So that's nice.
For sure.
Because, yeah, whatever we get on this one, then I'll go to the lab and I'll get some more explanation.
The distribution, standard deviation.
I'll be right back. I need to go grab my my charger.
Sure. Standard deviation. Oh, you know what? I think I figured. took the wrong formula for number 12 or 11.
Okay. I'm still trying to figure it out.
The mean of the distribution, the mean is going to be the same. So the mean that we had of 3.5 should be our sample mean as well. Because the mean is the same for the sample size as it is for the parent population.
That's true.
So that should be 3.5.
That's right. Okay. Well, that makes sense.
Gosh, why my brain could not figure that out a minute ago. Oh boy. Okay, mean. I need to really think about what I'm reading here. All right, now the standard deviation of the distribution of the sample means is the answer I gave you before. The 0.07 divided by the square root of 81. What did I say that was? Dang it. 0.077777. So
0.078.
Yeah.
0.078. Wow. This one's really working our brains.
Right?
It's not as easy as the videos look.
I know. Putting it into practice is a little more challenging.
Now I know why you couldn't hear me. I didn't have my right ear plug in with the mic on it.
Oh, gotcha.
Okay, so what do we?
Okay,
right,
so for 11,
we figured it out.
I figured out 11. What they're looking for is the mean. So for your sample size, your sample mean is always going to be the same as your parent population mean. So the 3.5 that they gave us for the mean is the sample size mean.
Okay.
Does that make sense?
Yeah. So it's just 3.5.
Correct.
Okay.
And then for 12, the standard deviation of the distribution of the sample means, that's the answer that I gave you for 11. Because I took the 0.7 and divided that by the square root of 81.
It gives you like she said, 7777. But if you round it up, it's 0.078.
Okay. So for 13.
We're on 13, right?
Yes.
Yeah. So the probability of the means, the students will be less than 3.3. So 3 minus 3.5 over.
Yeah, give me a second. Someone's at the door.
Okay. I got a z-score of -2, or I'm sorry, -0.286.
Huh.
Is that what you got?
No.
Okay, what did you get?
What? I didn't get anything yet. I'm still trying to figure it out. How did you get that?
Okay, so it's wanting probability. So for probability, we're going to have to figure out the z-score to throw into the applet.
Right.
Mm-hmm.
So I took.
So that's 3.3. The 3.5 minus the 3.3, right?
I did the 3.3 minus the 3.5.
Okay, there we go. Yeah. Yeah. Okay.
It's number minus our mean. And we know our mean is 3.5.
Mm-hmm.
and then divided that by 0.7. So I got a negative 0.2 over 0.7. And then once the division was done, I got a negative 2.86. Or negative 0.286, sorry. I'm putting that decimal point in the wrong place all the time.
-0.2886.
0.286.
Okay, so that one's just the same thing we did on number. Let's see.
But that's not your answer. That's just the z-score, so we can put the z-score in the app to figure out what the probability is. Because the question says, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? So we have to put that negative 0.286
into the app.
into the app and highlight everything to the left.
So then it's 0.387.
Yes. But
would that be all right?
Does that logic make sense?
Yes.
How I got to that point?
Yep.
Yeah. Okay. 2 more. We got this. It'll be great on the. Oh, this one's just the opposite. Now, for 14, it would be 0.613.
Well, it would be the difference of the previous answer from 1, because it wants everything greater than our 3.3. And since everything under the curve equals 1.
So 0.613, right?
Oh, yeah. Is that what you said? Sorry.
Yeah, he did.
Right.
Sorry, I had to work it out in my head.
You're good.
I think out loud sometimes.
All right.
So this is obviously not normally distributed.
Take 185 and subtract 177.6.
Getting hot here.
I think so. What size increases?
One.
Okay, so this assumes mean weight of the passengers in the commercial boat is 185. The previous value was lower, but then raised after a tragic boating accident. Standard deviation of passengers weight is 26.7 pounds. The weights of random samples of commercial boat passengers. Sample mean was determined to be 176.
Oh, sorry.
Standard deviation is 26.7 for sample size.
They're taking 185 minus the 177.6.
I'm taking 177.6 from the 185.
Yeah. That's 7.4 and then
And then you divide 26.7.
Well, wouldn't we want to get the probability of the distribution of the sample mean? But that's normally distributed. Small sample skewed. Hold on. It is not normally distributed. Can't use the applet because it's not normally distributed. So an extreme more extremes means we're only interested in values that are lower than the ones we observed, but also values that are far as far away from the mean as our positive direction. Find the probability that a random sample of passengers Any thoughts as to how to set this one up?
What if it's the z-score of So what if it's a z-score of 7.4? And then you take that, and that's what it's asking how extreme it is.
That I could see.
Okay, I came up with 0.055. I came up with, that's what I came up with.
For the z-score?
No, for the answer. So I took
Walk
the 177.6 minus the 185, which gave negative 7.4. Then I took 26.7. I'm using my Excel spreadsheet. So then I plugged in the 26.7 and the square root of 48, and it gave me 3.853813. And it gave me negative 1.92018. And then I plugged that into the app. It gives me 0.055.
Okay.
Because it's normally distributed, you highlight both sides, and it gives you 0.055.
All right. Well, let's
I got that one pretty good because I used my Excel on that one.
Okay. All right. I'm submitting.
All right.
All right.
How bad did we do?
We missed 2. Hold on. 15 is correct, 14 is not, and 13 is not.
Yay, mine was right.
Oh, wait, hold on. Yeah, no, just 14 and 13. Okay, unless I just plugged the numbers in for the wrong ones. I had 0.386 in for 13 and 0.613 in for 14.
Hello? Oh,
okay.
Did my phone die? Darn it.
I can hear you.
Do you guys know how to go back and view your answers? Like later on?
Yeah.
How do you do that?
You go into quizzes. Give me a second. I've done it in the past. I have to walk myself through it first. So you'll go to quizzes, and then whatever one you want to look at, there's that little arrow pointing down. You'll click on that, and it'll give you the attempts. You should be able to click on the attempt. It'll bring you to another window, and it will show you your answers to that quiz.
Okay, I see. Okay, cool. Cool.
Okay, so 13. What is the probability that the mean GPA for 81 randomly selected students will be less? Okay, so that's the one where we plugged it into the applet. So we had the right z-score of 0.078. Let's go back to Because that's, oh wait, that was the standard deviation. Bless you.
Thank you.
All right, so the probability that the GPA for 81 will be less than 3.3. Oh, wonder if that's why. All right, let me redo this problem. Standard. Probability of the mean GPA in students would be less than 73.5 over. Did we lose Gina?
Looks that way.
She was talking about.
So I'm gonna be talking to my tutor about it, just because I feel like I'm more lost than I should be.
Okay.
So if you want, I could let you guys know. So just let me know what questions you still want some help on.
Okay.
Because by the end of my tutoring, I'll know it all. Not humble brag, but no, I'll make sure that I understand it all, so I should be able to help you at the end of it. So yeah, if you just let me know which ones you need help on, I'll make sure that I talk to him about it.
Okay, well, so far the only ones that I need further clarification on are 13 and 14, the ones we got wrong. I'm going to try reworking them myself, but if you want to impart of any wisdom once you're done, that would be great.
Okay. Yeah. All right. Well, I think we are good then. I will
Okay.
We'll post this.
Sounds great.